January 5th, 2026, when 3i Atlas is already far away, its bright windows have passed, the news buzz has faded, and most have a comfortable feeling that the story has ended. And it's on this day that the most unpleasant part begins, because this doesn't feel like a flyby show. It feels like a scheduled operation, where Earth simply arrived at a predetermined point. The first warning signs appear not in astronomical timelines, but in places where no one expects a comet. Localized bursts, narrow bands of disturbances that don't fit into the usual geomagnetic pattern, appear on maps of the upper atmosphere. Not a planet-wide storm, not a general background. A clear line, as if the Earth were crossing a thin layer and the layer has a shape and direction. A couple of hours later, meteor data starts to trickle in, and it's no longer possible to blame it all on unclear sensors. Cameras around the world begin to pick up not a beautiful meteor shower, but a strange pattern of arrivals, short bursts of fireballs, flashes in groups, sometimes at regular intervals, as if the shower is coming in packets. It doesn't look like a random swarm. It looks like a ribbon with dense pockets within it. The most important thing is that at this point, Atlas can't be used as an excuse, like it's nearby and disturbing everything with gravity. It's far away. This means that if Earth entered something today, that something was left in space beforehand. And then the scenario becomes more complex. We're not dealing with a flyby, but with a trace intersection, and this intersection depends solely on our orbit. We arrive there ourselves, on schedule, like a train at a station. The official line initially sounds perfectly dull. Probably a seasonal surge in meteor activity, possibly related to the dust trail of an interstellar object. Data is insufficient. This is the kind of language that buys time. The problem is that time isn't bought when independent systems begin to converge simultaneously: optics, meteor radar, infrasound, and then anomalous notifications in low orbit. Because alongside the fireballs, another, more dangerous part of the picture is emerging. Operators at LEO are starting to see an increase in unexplained proximity warnings. Not large debris, not catalog pieces, but short blips that last for minutes and then vanish. There aren't enough of them to be considered satellites. There are too many of them to be considered algorithmic quirks. And the worst part is that these blips appear in waves, synchronous with atmospheric surges, as if the Earth were simultaneously touching the same layer from above and below. At this point, one of the analysts utters a phrase that usually quiets the room. It's not a tail, it's a trap. Not in the movie-style explosive trap, but in the sense of a thin, preset band of particles that's impossible to bypass if you're a planet in orbit. You either cross it or you don't, and if you do, everything else depends on what's in that band. On paper, this might be trivial. The comet left dust behind and it crossed Earth, but reality is all about the details, and the details are poor. The stream doesn't behave like uniform dust. It behaves like a material that sticks together, that produces portions, that creates series, not chaos. And if this is truly the trace of Atlas, then the question is no longer why meteors, but why structure. By the evening of January 5th, another layer of data arrives, which completely undermines the rosy theory. Several laboratories that automatically classify fireball spectra are showing the same anomaly, lines that normal meteors don't like. The peaks are too sharp, the pattern too repetitive. This isn't proof. It's a reason for immediate silence, because any public statement here becomes a commitment, and that's precisely why the next morning a closed chain of phone calls begins. Agencies, satellite operators, space situation services, those responsible for communications and navigation. Publicly, they'll say, there's no threat. Internally, they'll decide something else. Is this a one-time crossing pocket, or has the Earth entered a path that will return again? 2 more, 10 more, until we've passed through it completely. The most unpleasant conclusion sounds simple. Atlas is already gone, but its work could still be here. And if this is true, then January 5th marks not the end of history, but the moment when history finally begins to bite. They don't gather in a large hall or at a press conference. Everything happens more quietly. A closed call, short speeches, recordings turned off, no extra people invited. And the first thing they hear isn't meteors, but geometry. Because meteors themselves don't prove anything. But when bursts in the ionosphere form a streak and fireballs arrive in batches with similar spacing, it ceases to be weather. It begins to look like a structural intersection. Someone throws a simple image onto the shared screen. Earth's orbit, the predicted Atlas track, and a thin sector where all the signals coincide. The sector isn't wide, not all over the sky. It's a narrow arc, as if someone drew it with a ruler. The most disturbing part comes next. If this is dust, why isn't it smeared? A typical comet trail spreads, dissipates, and is blown by the solar wind. But here, There are pockets of density, almost uniform, like knots in a rope. And here's where those astronomers usually don't like to mention come into the conversation. Catalog operators, space situation services, people who live by the warnings of close encounters and know the price of false alarms. They show a graph of unexplained objects on Elio over the past 24 hours. The peaks coincide with atmospheric bursts down to the minute, and this no longer looks like algorithmic noise because noise can't synchronize. Someone cautiously says, perhaps these are microparticles that are clinging to the equipment and producing phantom tracks, and they immediately respond, then why did the phantoms appear the same on different systems? Too smooth, too consistent. The coldest voice on the call utters a phrase that usually makes your stomach churn. We don't see garbage, we see a routine. It doesn't matter whether it's natural or not. What matters is that it's repetitive and has a rhythm. After that, the math begins. They take the fireball sequence, take the time and camera coordinates, take the radar tracks, and they try to reconstruct what the ribbon in space looks like as the Earth traverses it. It's not pretty. The ribbon doesn't follow the orbit exactly. It's tilted, seemingly cutting the Earth at an angle, first catching the upper atmosphere and then, hours later, sending a signal to low orbits. This is the most disturbing thing about this version of events. The trace behaves as if it were designed for a multi-layered test. First, check the ionosphere, then check navigation, then check the orbital situation, and all this without Atlas being nearby. In public, everything looks dull during these same hours. A couple of dry notes about a possible dust component, nothing about synchronicity, nothing about the runway, but within the call, a second window appears. Communications, because in several regions, strange, brief degradations are starting to be recorded. Not a massive blackout, but micro breaks, as if someone were touching the upper atmosphere with a finger. And this, again, fits the same geometry. One engineer shows a weather satellite log. The sensors see a brief spike, then a dip, then a repeat at regular intervals. It doesn't look like a solar storm. Storms don't have a neat tick-tock pattern. And this is precisely where NASA has an excuse to shut down the public discussion completely. Because if they say, it looks like a pattern, tomorrow journalists will ask one question. Who made the pattern? Inside, another question is being asked, more practical and more terrifying. What exactly are we crossing? Dust is one thing, micro debris is another, and then there's the one no one wants to be the first to say. The answer is simple, active fraction. Particles that don't just fly, but carry a charge or have unusual magnetic properties or produce a chemical response in the upper atmosphere in a way that ordinary dust can't. To avoid guesswork, they cling to the only thing they can quickly verify, the spectra of fireballs. And then a strange thing emerges that makes the chemists' faces change. Repeating lines. Too similar between different inputs. Not we've found alien metal. No, much worse. We see the same profile in different parts of the world. What should be different by definition looks suspiciously similar, and then someone asks a question that sounds like a slam on the table. Why the same? If it's a random swarm, it's bound to be messy, mixed, and heterogeneous. But here, it feels as if the material was selected, like a batch. By the evening of January 5th, a preliminary reconstruction was put on the table. The Earth had entered not a broad tail, but a thin path, running along density nodes. The nodes produced bursts of fireballs, and the gaps produced silence, and that explains the strangest thing, why everything looks like a series, not like rain. Because it's not rain. It's as if invisible markers were placed along your orbit, and you simply pass them one after another. Next comes a quiet but important step. They stop posting some telemetry in the usual open streams. Not because there's a conspiracy, but because they understand the cost of panic if they made a mistake on the first day. But it doesn't smell like a mistake by the second day, because on January 6th, closer to the morning, a weak response begins again. Fewer fireballs, a thinner band in the ionosphere, but the pace remains similar, and here's where the most unpleasant thought arises. We didn't cross this once. We enter a cluster of paths like a comb. Today, the first, tomorrow, the second, the day after tomorrow, the third, and each one tests something different. During the call, they utter another phrase, seemingly mundane, but more terrifying in meaning than all. We must understand whether this is a remnant or a mechanism. The remnant dissipates and dies. The mechanism repeats. One photograph shatters the calm narrative not because it's beautiful, but because it matches calculations no one wanted to voice out loud. It shows neither rain nor scattered snow, but a narrow thread, like a scar. It's not sent by an observatory or an agency. It's sent by a private individual who simply enjoys photographing the sky and records everything, like an accountant records receipts. He doesn't have access to confidential data, but he does have a habit of not deleting anything. The image was taken during the very same period when the large systems were showing a normal background, not because they were lying, but because they were using filters that filter out the garbage and leave only what looks like astronomy. There's no bright comet nearby in the image. Atlas is already far away, and that's important. It's not present in the field as an object, but there is a thin band of faint flares in the field, and the band falls where calculations predicted a knot. At first, they think it's a plane track or a defective sensor. Then a second email arrives from the other side of the world, from a different person. A different telescope, a different camera, a different time zone. The stripe is the same, it's not similar, the same geometry, with the same barely noticeable break in the middle, as if the ribbon were making a small step in space, and the Earth, passing through, detects it as the edge of the atmosphere. This step is their nightmare, because a random trail doesn't create steps uniformly, especially within hours, and the knot calculation only works if we assume the trail doesn't decay randomly. Then they do something they hate to do in public. They rewind time and recalculate the intersection not of a comet tail, but of a specific ribbon in space, as if it were a thin stream of particles. The result is an unpleasant picture. The tape doesn't spread, but holds its shape for several days. It has dense sections, empty sections, and repeating patterns as if someone had cut it into sections. And even worse, the step between sections is close to constant. Not perfect, but too precise for nature. It's not a metronome. But it's not chaos either. It feels like a compromise between the plan and the environment. Someone on a call says, if it's artificial, it could have been staged in advance. The phrase sounds unimaginative, almost dry, like a journal entry. It could have been staged deliberately. And this is where a strange detail emerges, previously swept under the rug, to avoid blowing it out of proportion. Several major observatories did indeed produce empty images in the right window. Not all, but enough. Where private operators see a weak band, automated pipelines see a blank sky. And this is explained simply, the systems are trained to discard linear structures, because linear structures are almost always garbage. But this debris turned out to be the most important, and now they need to prove to themselves that they're not crazy. The stripe should appear again if the ribbon really exists, and if Earth is entering the next section, they look for a forecast for the next touchdown and find a 38-minute window. It's small, awkward, and doesn't offer a great picture, but it's in the same spot where there was already a weak replay this morning. Then begins a hidden race that no one would call a race. Who will be able to set up the devices in time to avoid filtering the signal? Who will be able to capture the raw data without subjecting it to the usual sterilization process? NASA is pulling one line, ESA is pulling another, and they're trying to gather private companies into a third, because they're the ones willing to turn off autocorrections and write everything as is, even if half the frames are garbage. And at this point, the conversation suddenly turns cold, because they're bringing in those who look not at beauty, but at reflections. Radars aren't supposed to see a comet's tail, but they are supposed to see density and structure. A short sign appears in the closed channel, stable reflection. Not a cloud, not noise, not a single flash. A series of dots lined up along a line as if something small were marching in formation. Not ships, not platform, simply a fact. The reflection lasts longer than a random dust cloud should, and it stays where the intersection geometry promised a node. At this point, they're no longer debating whether it's nature or not. They're arguing about something else, whether it's dangerous for the satellites or not. Because if the tape is truly sticky, the next knot could align with the orbits, and then they remember the LEO proximity warnings. Those phantom objects that appear precisely in the right sector. They're no longer called phantoms. They're called unaccounted for environment. One person shows a graph of Starlink-like constellations. Small disturbances, tiny changes in resistance, micro-corrections that usually dissolve in the statistics, but today they're all in sync. The tape doesn't hit everyone, it affects those who pass along a specific line. It looks like a thin knife drawn through the upper atmosphere and low orbits simultaneously. Someone suggests a simple test, an artificial beacon in the upper atmosphere, launching a chemical marker to see how it deforms at the proposed node, and immediately receives the answer, there's no time, because the window is close, because the bureaucracy won't have time, because the only thing that can be done quickly is to collect the raw data and compare it with each other without filters or beautification. And finally, the hour begins, for which they all sit silently and without jokes. Cameras, which no one usually considers serious, are turned on around the world, not because they are better, but because they are simpler. The signal doesn't appear like a firework. It appears as a subtle degradation, like goosebumps. The noise increases on the spectrograms, and the noise doesn't increase uniformly, but in a band, as if someone had applied power. Then short fireballs appear on the night sky cameras. Not bright, fast, and the worst part, they're not random. They follow the same path, almost like rails, one after another. At this point, the calm version dies completely, because the coincidence doesn't repeat itself so neatly. A coincidence can flare up once and then disappear. But here, the knot works like a knot, twice in a row. And just then, the third frame from a private seller arrives. It shows something that people don't even like to say. A point source appears briefly near the path, faint but stable for several frames. It doesn't sit on the stars, it's held relative to the path. It's not a satellite, because a satellite would shift differently. It's not a glint, because a glint doesn't repeat in two different systems simultaneously. A second, two, three. The dot holds, then it disappears. And at that moment, someone writes a single word in the chat, emotionless, like a marker on a map. Beacon. The word beacon hangs in the chat just like a red dot on the screen during an alarm. No exclamations, no emotion. Just a marker that makes everyone speak quieter and faster at the same time. 30 seconds later, a short command is sent over a secure line. Collect telemetry, extract raw footage, freeze public releases until re-verification, not because we're hiding it, because if it's true, any future mistake will be historic. Meanwhile, the orbital duty officer has another alarm. It's not about fireballs, not about the atmosphere, but about an anomalous correction in a pair of devices in low orbit. It's a small thing, but it fits in the same pattern, as if someone had drawn a ruler. A series of dots appears on the radar screen, and for the first time, someone says the important phrase out loud, "That's not a cloud." The cloud dissipates. Here, the dots hold their shape and return to where the next section of the tape should be. The most disgusting thing about this picture is that it doesn't require imagination. It only requires discipline. If the ribbon is cut, a beacon can appear at the boundaries of the sections, and then it can be predicted, just as a node in orbit is predicted. They immediately do what they usually do after an accident, collect independent clocks. Some data is converted to UTC, others to TAI, and still others to local camera timestamps. A single second error here would ruin everything, and then it becomes clear why the large systems saw nothing. Their pipelines are designed to discard linear artifacts and point like flashes that don't behave like stars. They dismiss the signal as junk. What saved the private photographers was their poverty. They don't have perfect filters. They don't have beautiful calibration, but they do have raw footage that shows dirt, noise, and that very spot next to the path. Inside NASA, someone opens an old folder with the awkward name, Co-Moving Sources, and posts a link to the chat. It contains a list of situations where a point sticks relative to an object, although it should be moving across the sky. The next 10 minutes become a hunt for something they usually don't catch: behavior. They're not interested in brightness, they're interested in how the dot moves relative to the path and the starry background. The first calculation yields a strange result. The dot has almost no displacement of its own, as if it were attached to the ribbon. But the ribbon itself is no longer a comet, and this undermines the usual explanations about tail particles. Then another layer is added: radio lines. If it's a beacon, it might give a weak response in a range typically untouched by civilian astronomy. This isn't an SOS signal, it's a signature of the process. A phrase appears in a closed channel: recheck X-band background, and another, more blunt one: do not publish raw spectra until verified with radar. In other words, even a hint of a frequency becomes sensitive. Right at this moment, something happens that would be news in a normal week. One of the space instruments, which was supposed to provide independent verification, suddenly goes into protective mode. Not for a day, not later, out the window, into that very window when the next section of the feed should be replaying. And the short word appears in the chat again, only this time it's different. Second time. Someone pulls up the shutdown telemetry and notices a strange pattern. Before safe mode, there's the same sequence of power and orientation, as if the system is reacting not to an error, but to an external load. Nobody likes this phrase, but it comes up naturally: sensor overload. That is, the device didn't break, but rather saw too much, too sharply, and went into overdrive, like a person covering their eyes from a flash. Now comes the most dangerous part, psychologically, because if it's an external load, then it must have geometry, and they already have geometry, the Earth ribbon point line. They take a map of the ionosphere, typically of interest to radio amateurs and the military, and superimpose it on the node path. The burst turns out to be localized and elongated, like a knife cut in the upper atmosphere. This isn't a storm or general solar activity, it's a line that coincides with the same path where cameras detect fireballs and radars detect steady reflections. At this point, the internal logic changes. They stop talking about Comet Trail. They start talking about Wednesday. It's as if a band of a different regime has appeared near the Earth, thin but physical. And if it's an environment, it could be dangerous, not because it falls on us, but because it interferes with orbits and electronics. It doesn't destroy them, but rather tests how the system reacts, nipping at the edges. Immediately afterward, an order comes out that sounds dull, but sounds like a siren. Restrict access to observation windows by prior arrangement. Publications are to be made through a unified protocol. Private operators are to be carefully removed from the coordinates. On paper, this is called information risk management. Essentially, it means that if people start looking where they are now, more footage will start appearing, and it will no longer be possible to reduce it to an artifact. The worst part is that they have to choose. Either the public immediately learns about the node and starts filming the sky en masse, generating thousands of fakes, or they hold on until ironclad verification is achieved, and then, as luck would have it, the private operators are back on the attack. A short post appears on forums. Guys, it happened to me again, in the same window, and the dot was right there again. The post doesn't have coordinates yet, but it's just a matter of hours. Silence descends within the chat, because this isn't just one or two incidents, this is a cascade looming, one that can't be stopped by an order. It can only be outpaced by precision and explanation. And then the most nerve-wracking thing happens. One of the calculators writes, if the dot is stuck on the section boundary, the next one won't appear tonight. The next one will be in 2 days, and the window will be more ideal. This means the beacon isn't a random blip, it's a schedule. And if there's a schedule, it means someone has already done the work in advance, posted the feed, cut it, and is now running a replay as a test. Then they do the only sensible thing, set a trap for the data, not the object. They set up independent cameras, disable filters, record raw footage, synchronize clocks, and prepare triangulation across 2 continents, because if the dot reappears, it can be captured not beautifully, but geometrically. And then it will become clear what it is, a reflector, a plasma inhomogeneity, a compact source, or something maintaining its position relative to the strip. And at this point, history acquires a new center of gravity. No longer Atlas, which is somewhere far away, but the ribbon near us which we touched and the dot next to it, which comes and goes like a mark in the fields. Next time, they don't expect beautiful shots. They wait for seconds, because if a beacon lives on the boundary of sections, it reveals itself not by the image, but by synchronization, and only clocks and geometry decide here. The first command sounds dry. Remove auto pre-processing. No cosmetic filters, no peak suppression, no smart artifact cleaning. Let it be dirty, as long as it's fair. The second command is quieter and more unpleasant. Create a network. Not just one observatory, not 2 telescopes, but dozens of sites that don't know each other's target coordinates until the last minute, to eliminate common error. The third command is a real pain in the ass, to activate things that aren't usually mentioned in public releases. Long-range radar, ion sounding, GNSS interference monitoring, telemetry from orbital vehicles that accidentally observe that sector. Because now the hypothesis is different. It's not the comet is acting strangely. It's there's a thin band of environment around the Earth and it's reacting to observation. And if it's reacting equally to different systems. That same evening, a corridor is drawn on the internal map. It's thin and elongated, as if scratched by a fingernail through the upper atmosphere. The corridor runs where, according to calculations, the next section boundary should be. Meanwhile, the technicians are doing what they usually do before a rocket launch. They're checking the time. Not against a computer, not against the internet, but against disciplined sources where a millisecond error is considered a failure. For amateurs, it looks ridiculous. A box with a GPS mount, a cheap oscillator soldered together on the fly, and a camera that records raw, uncompressed video. But that's exactly what's needed. At large observatories, things are more serious. There, timestamps are kept according to internal atomic standards and the logs are written in triplicate. Because if the beacon appears again, the logs will be the subject of dispute. NASA is launching a separate channel with the short name Parallax. Its purpose is simple, to capture the same moment from 2 distant points and obtain not an image, but a distance. And this is where they first become truly uneasy, because calculations show that if the dot is truly held relative to the tape, the parallax will be tiny, like that of an object that is too far away. But the radars whisper otherwise, a steady reflection, almost like from a compact structure. Not constant, but switching on, precisely at the windows, as if someone were supplying power on a schedule. By midnight, a word no one likes starts to crop up in closed chats. Protocol of silence. It's not about a conspiracy. It's about the fact that if the coordinates leak, the internet will be overwhelmed by noise and fake news, and yet leaks still happen. Not coordinates, but a hint. Watch the sector between the bright landmarks. The window is short. There will be a repeat. It's enough to send thousands of people scrambling for the skies. They know the internet will be filled with junk. So they need one thing, a clean signal from pre-prepared platforms where people aren't filming for hype, but for geometry. The window is set for 2:17 UTC. At this time, the band should cross the very line where the beacon appeared earlier, and the ionospheric cut should produce the smoothest outline. 10 minutes before the window, one weather satellite detects a localized spike in the ionosphere. It's neither a storm nor background noise. It's a narrow band, like a thin scar, aligning with the calculation corridor. A minute later, a second signal arrives. 2 satellites in low orbit are receiving a sharp increase in the number of warnings about approaching objects not listed in their catalogs. Not many, but enough to raise eyebrows. And at that very moment, a familiar pattern appeared on Hubble's telemetry data, the same one that occurred during the first safe mode. First, a slight power surge, then a strange drop in one of the attitude sensors. They haven't shut down yet, but we can already see where this is heading. The worst thing isn't the shutdown, but the repetition. 2 identical sequences on different days. That already looks like an impact, not a coincidence. 2:16:50. The network is already recording. 3 platforms in different time zones are hosting the same sector. All have their smart filters disabled. All have raw footage. All are synchronized to a reference time. 2:17:18. A dot appears in the amateur shot. Not bright, not pretty, but firm. It stays close to the track as if nailed in place. And it lasts not a frame, but seconds. 2 hours, 17 minutes, 24 seconds. The radar returns a response. Short but confident, like a compact reflector that's caught the right angle. The next mark is where the next edge of the section should be. 2:17:31. Another localized burst erupts in the ionosphere. Not a stripe, but a knot. A pinpoint peak as if someone had jabbed a needle into the upper atmosphere and released it. 2:17:40. And here's what's happening. The very reason they built the network. 3 independent telescopes in 3 countries are experiencing the same dip, exactly 1 second. Not a loss of focus, not a cloud, not a plane, not a camera flickering. In the same second, the signal in the frame turns into background, as if someone had cut out a layer and left only the stars. The logs make it look even worse. At the same moment, the orientation sensors on both platforms show a micro jump, as if the system had caught a false reference point and then immediately lost it. And right on top of this, Hubble's telemetry is layered. It doesn't simply go into safe mode. It does so at the same pace, in the same order, and with the same warning about the load on the same circuit. Someone in the chat writes, "They're doing it while we're watching." And this is the first time "they" sounds like not an emotion, but the briefest explanation of a pattern. Because if it's just physics, it doesn't have to be the same second for 3 independent systems at once, and if it is, it means there's a trigger that hits everyone equally. A minute later, another shock to the piece arrives. The military radars give another response, but this time it's flat, like coming from a surface, and immediately after the response, there's emptiness, as if the reflector had been turned on its edge. Then a hypothesis emerges that leaves your mouth dry. The beacon isn't a light or a motor, it's a compact module next to the tape that opens for a few seconds to test the reaction. To test not the Earth as a whole, but our vision, our sensors, our filtering algorithms, our habits. And if it sees that it is being seen, it can, for a second, make us see only the background. Now it all starts to look like bad math. If they have a disappear for a second mode from optical signals, it'll probably work for radar, radio links, and any systems that search for a stable signature. If that's true, then the tape isn't garbage. It's a route. And the beacon isn't a random point, but a tool that follows the route and marks its boundaries, like marks on a tape measure. At the end of the window, they get the final frame, the most unpleasant one. The dot doesn't simply disappear, it moves to the side at a fixed increment, as if jumping to the next position, and then fades out. And it was at this point that one of the planners wrote briefly, "The next jump will be in 6 hours. The window is 4 minutes. The geometry is better. If we don't catch this, it will be too late." They call the replay window 6 hours, but in reality, they have less. While some are writing calculations, others are reprogramming the cameras to ensure that no smart algorithm misses exactly what they're supposed to catch. They make the most important decision right away. They don't trust pretty pictures the second time around, only raw footage, only raw logs, only pixel perfect, even if the viewer is later shown something completely different. They divide the network into 2 layers. The first layer pretends to observe as usual, so as not to change the background of events. The second layer remains silent and writes in the shadows, without publications, without broadcasts, without external signals. Someone suggests a simple trick, announce a false window time in public chats, so that noise and random cameras will be directed to the wrong places. This isn't a conspiracy, it's sanitation. Otherwise, an ocean of garbage will drown out the signal. Half an hour after the first window, a graph appears on the internal server, causing a complete silence on 3 platforms. The second long dip coincided within tens of milliseconds, as if triggered by a common trigger. What's worse is that the dip isn't uniform in brightness, but it's uniform in shape. First, there's a sharp drop in signal, then a flat plateau, then a return. It looks like a mask, not a flicker. If this were a cloud front or local turbulence, the shape would be different. But here, the geometry matches. This happens when the intervention occurs at the processing level or at the input level. They argue for 2 hours and come to a common conclusion. The beacon doesn't just glow, it can trigger the surveillance chain so that the camera accurately records the background, but not the light itself. At this point, the next question arises, the most unpleasant one. Why then are there even seconds when he's visible? So he doesn't hide himself all the time. He does it selectively, like a test. And then they recall the ionospheric knot. The peak doesn't resemble a storm, but rather a local response, as if someone had briefly tapped the upper atmosphere and listened to the reverberation. The new hypothesis sounds dry. It's calibrating the environment. Not to attack, but to understand the parameters. Densities, conductivity, delays, interference immunity, everything needed for working near a planet. The next window is scheduled for 0817 UTC, and this time, they're adding another layer, one rarely used in a story like this. They're raising the amateur radio network, not by sky, but by spectrum. They care about one thing, not the voice, not the transmission, but strange, narrow lines that shouldn't be there. If the beacon is functioning as a device, it can leave a trace in the spectrum even when hidden in optics. An hour before the window, unpleasant news arrives. An internal Hubble report confirms that the same sequence of events repeated itself before safe mode, and this does not appear to be a random degradation. What would be a normal failure in the official wording appears in telemetry as a controlled chain. First a power surge, then a false positive, then a protective shutdown, just like in a textbook. And here, for the first time, people start talking not about a comet or dust. They start talking about a system that can turn off the sky for a minute if the sky is watching too closely. At the second screen, they decide to go head on. The 2 sites receive different targets on paper, but the same actual target at the last moment. If the mask matches with different inputs, it means external interference. From the outside, it looks boring. A few telescopes, a few radars, a few sensors. Inside, it looks like a hunt for an invisible habit, repeated strictly according to time and geometry. 8:16:40. The ionosphere is calm, the background is clear, and the noise is low. The satellites in low orbit are maintaining their normal state. LEO operators are tired of the warnings and are starting to get angry at the phantom objects. 8:17:05. The first strange sign doesn't come from the optics, it comes from the spectrum, a narrow line at a frequency where nothing should be flashes for seconds and then disappears as if someone blinked a transmitter. 8:17:14. The radar again gives a short, steady response. This time it's slightly offset, as the calculator predicted. The offset is exactly 1 step, as if the marker had moved along the scale. 8:17:19, a dot appears on 2 telescopes. On the third, it doesn't. Not because the optics are worse, but because at exactly this second, the third telescope reports a clear background, as if the object has been cut out of the frame. This is the moment when their throats go dry. Because the 3 stages are synchronized, the sector is identical, the exposures are coordinated, but the results diverge, as if the subject is choosing who to show herself to. 8:17:21. And immediately the familiar pattern repeats itself. A momentary dip, a flat shelf, a return. But now, not everyone experiences the dip. It's only those who maintain the correct angle. This breaks the last calm theory about a chain error. Error doesn't choose an angle. Error doesn't understand geometry. And here it's as if someone is aiming not at the telescope, but at the observation line. They record the next 30 seconds as if in a fog. The dot hovers near the tape, then steps off, then reappears where the next mark should be, and then fades out again. And then that 18 minutes happens, the kind of thing that will be debated later. Not a 1-second gap, but a pattern of gaps. Major observatories publish blank images almost simultaneously, not accidentally empty, but perfect. The stars are sharp, the background is smooth, and noise is minimal. In other words, the system works perfectly. Except for one detail, the very object they're waiting for doesn't seem to exist in the frame. Amateurs who wrote raw images without pipelines have an object. It's weak, but it's there. And what's even scarier is that it exists at 2 points in the world at once with the same step pitch. This creates a rift. Official chains show clear skies. Raw data shows yes. And the dispute here isn't about trust, but about what exactly the official chain has discarded as incorrect. Then one engineer does something simple, something no one usually does in a live science broadcast. He runs the raw footage through a filter that mimics the official pipeline, step by step. And at one point, he catches the moment of truth. The pipeline sees a point, classifies it as an artifact because it's too stable relative to the target, and discards it as junk. Too stable. That word kills everything. Because for a comet, a stable point near the active medium is an oddity. But for a beacon device, it's the norm. And it's precisely because of this norm that it's being thrown out. Then they find a second knife. The burst suppression algorithm, which is supposed to remove cosmic rays from the matrix, coincidentally matches the shape of their 1-second dip. If someone knows how their processing works, they can hide in the area the algorithm considers garbage. They don't break the chain. They simply mask it, and the chain resets itself. And at that moment, the story stops being about the sky. It becomes about how an object that should have long since departed remains nearby and can already speak to us in the language of our instruments. They don't write it in the report. The report will say anomalous correlation, possible processing error, requires verification, but inside the room, everything sounds simpler and more frightening. He realized how we look. They don't schedule the next window for 6 hours. They schedule it for a day. Because if the beacon jumps around the scale must have a cycle, and they are obligated to calculate that cycle. And it's precisely at the end of the day that a new detail appears, shattering any hope of chance. The false star appears again, in the same geometry, at the same step, at the same second. And at that moment, Hubble again shows a tremor along the same contour. Not safe mode right away, but a precursor, as if someone had touched the same nerve again, testing whether the protection would activate. And then, someone says something that makes it impossible to pretend it's just a comet. This isn't an attempt to hide, this is a test of our reactions, and he repeats the test because he's learning. At the end of this part, they have only one solution left. Stop playing tag and create a trap in which the subject chooses what to reveal. A trap in which the mask becomes evidence. At this point, they begin preparing the third window, the most dangerous one. It won't just be optics and radar, it will also involve geometric provocation to see if the beacon responds to our choice. And that night, for the first time, they ask the question out loud. What if the ribbon around the Earth isn't a trace, but an instrument? And what if we're already in the zone where it's not the planet that's being measured, but us? They use the third window not as an observation, but as a reaction test. Not to catch the subject, but to force them to demonstrate whether they can distinguish an accidental glance from a deliberate one. The first rule is simple and brutal. No public schedules, no, we'll watch at 2:40. If this phenomenon has access to our discipline, it must not be given any hints. They pretend to be chasing their tail, but their real target is in another sector. The internal plan is changed 15 minutes before takeoff, after the targeting teams have dispersed. By this point, people who aren't usually present in such chats enter the picture. Satellite operators, communication specialists, receiving station operators, those who understand that any quirk in the optics always leaves a trace in the radio links. They need one thing, a control pulse that will travel through the chain, not through the telescope, but through the sky, through the ionosphere, through delays, through the air that no one usually considers part of the experiment. The setup looks messy, but it works. 2 ground-based transmitters produce short ping windows on different frequencies, and a network of receivers around the world records what's returned and how it's been distorted. Nobody mentions the word object connection. Formally, it's called calibration, but everyone understands. If there's something active in the sector, it will leave an imprint, at least in phase, at least in noise. An hour before liftoff, another piece of cake is thrown onto the table, which finishes off the calm ones. The false star line coincides not only with the comet, but also with the node where the orbit intersects the Earth-Moon observation plane. If it's a coincidence, it's too beautiful. If it's a route, it's designed so that the moon, at just the right moment, covers half the sky and cuts off corners for us, leaving only corridors. And here's where the new purpose of the provocation emerges. They want to test whether the object responds to lunar coupling, to the geometry that forces us to change modes and break out of our comfortable filters. The plan is simple. Some telescopes hold the object, some hold a blank background nearby, and some look where the object should be hiding if it chooses to hide due to lunar illumination. If the mask appears again, they'll see its shape everywhere. If the mask is angle dependent, they'll be addicted. And if the mask is moon dependent, that'll be the worst possible answer. The window begins quietly, too quietly. No spikes in the ionosphere, no ping anomalies. It's as if the sector is dead. This frightens them more than the noise, because the previous times there were traces, a second, a shelf, a return. but now it's as if someone had already evened out the background, as if they'd entered a mode where the subject doesn't make mistakes. And right against this backdrop, the first irregularity emerges. Not a dot, not a tail, a band in the spectrum, narrow, clear, as if someone had briefly turned on a beacon at a perfectly even frequency. The stripe doesn't look like terrestrial debris. Terrestrial debris has jitter, side lobes, and dirt. Here, the line stands like a needle, then disappears as if turned off by a timer. Seconds later, one of the receivers experiences a phase jump. It's small, almost within the error margin, but it's repeated at the other two stations and with the same delay. This is the moment when calibration ceases to be a word, because calibration doesn't choose the same latency in different parts of the world unless someone has conditioned the environment to behave the same way. Then everything happens quickly. The object is present on 3 optical platforms. On 2, it drops at the exact second they switch to a more sensitive mode. Sensitivity is supposed to help you spot weaknesses, but here, it's like it's turning on protection. The pipeline starts suppressing artifacts more aggressively, effectively cutting out anything too stable. They catch this in the logs right at the moment the classifier flag changes. Celestial object turns into local defect, and the frame is sent to the filter bin. This time, they're ready. They write the raw data to a separate drive, bypassing the filter, and the object doesn't disappear from the raw data. It simply takes a step, as if moving along a grid. The step is the same as in previous windows, not a smooth drift, but a discrete shift, as if the marker were jumping to the next node, and this happens synchronously with the phase, jumps in the radio link. Here, finally, they have a thread they can pull. If the optical phase and the radio phase match, it's one system. Not chaos, not dust, not a ripple. And almost immediately, a second effect appears. At the moment of the step, the ionosphere produces a localized burst. Not a wide one, but a narrow one, elongated along a line that coincides with the Earth-object-moon geometry. It looks like a scan. It's as if someone is running a beam across the upper layers and observing how the conductivity changes, how the delay varies, how the plasma reacts. The most disturbing thing about this is that the Earth in this scheme becomes not a target, but a device. The planet as an antenna, the atmosphere as a screen, and someone is checking how we respond. 10 minutes into the window, one LEO operator posts a message that stops people typing. Proximity alerts cascaded. Sectors are the same. Times are the same. What previously looked like statistical noise now fits into the same timing as the false star step. First the spectral spike, then the step, then a wave of phantoms in the catalogs. And then an option emerges that one wants to dismiss, but it explains the form too well. The false star may not be a light, but a tracking marker, a small satellite near the object, or a detachable element. Something that hovers relative to the core to measure distance, orientation, angles, anything that's convenient to measure in pairs. If this is true, then the core swap between different telescopes also ceases to be a mystery. Different instruments could have picked up different components of the system and combined them into a single image in different ways. Some saw the core, others saw the mark, still others saw the tail and considered it the main one. And the result was, the core is different, although in fact, it was what they mistook for the core that was different. Next, they do something that usually takes weeks and approvals. They gather data from civilian telescopes, amateur telescopes, weather satellites, and a short fragment of radar logs onto one table. Time is superimposed on top, geometry is superimposed on the bottom, and suddenly it becomes clear that events aren't chaotic. They repeat themselves as the object passes through specific sectors relative to the Earth, and this kills the idea of just a flyby, because a flyby passes by and disappears. But here, the object seems to move in circles, choosing angles where it's convenient to test the environment and where it's inconvenient for us to watch. At this point, they make a new decision. The next window will be bait, not a trap. They'll deliberately create a noticeable observation signal to test whether the target responds to our interest. Not directly, not by beam, or by attempting to connect, but through network behavior, by activating those channels that are visible from the outside. Station activity, telemetry modes, schedules. If a mask appears after this, it means it's tracking not only the sky, but us as well. If no mask appears, it means it's only responding to geometry and the environment. And that will be an answer more terrifying than any clearly structured frame. Because then we'll understand that there's a second observer in the story, and he's been more than just flying.